Consider the vectors A is equal to I plus j minus k, B is equal to 2i minus j plus k, and C is equal to 1 by root 5 into I minus 2j plus 2k. What is the value of C dot A cross B? So the moment you see this, what is that we have been trying to find out? The scalar triple product. And how do we find the scalar triple product? Determinant of these vectors: 1, 1, minus 1, 2, minus 1, 1, and 1 minus 2, 2, 1 minus 2, 2. So to find the determinant, what I'll do is I'll multiply this row with R1 tends to R1 into 2. Okay, so what do we get? What we get is 2, 2 minus 2, right? The rest doesn't change. 2 minus 1, 1, 1 minus 2, 2. And then in this matrix, what I'll do is it should be understood that we divide this by 2 also. Then what we do is multiply the second column with minus 1. So again you have into minus 1 here. So how does the value changes now? 2, 2, 1. The first and the last column won't change. What will change is minus 2 plus 1 and plus 2, right? Multiplying minus 1 here. And now if you see, these two columns are the same. Therefore, what is the value of determinant? Determinant is 0, which means the scalar triple product is equal to 0, which means the correct option is option B, right? Now, let us write a couple of more points regarding this. Okay, let us find this answer in one additional way, which would be like this. See, vector C is 1 by root 5. Okay, I think it's better that we discuss what's the scalar triple product. That would suffice the discussion. So let us now write down the basic properties of scalar triple product, which will help you to understand the concept better. So we have scalar triple product, right? What is the meaning of scalar product? It goes like this. So scalar product can be, okay, so scalar product of 3 vectors, right? Of 3 vectors. Scalar product of 3 vectors A, B, and C is defined as the scalar product of, right? The scalar product of vector A with the or to be more precise, with the cross product of vectors B and C. So it is the scalar product of vectors vector A with the cross product of vector B and C. Now, how does this represented mathematically? So what we do is we use the symbol like this: triple product A, B, C. Or this can also be written as A comma B comma C, or this is also written as vector A dot B cross C. So this is the basic definition of scalar triple products. Now, what we need to understand is a couple of basic identities based on this, which goes like this. Right, so let me write it here. So we have triple product ABC of vectors ABC is equal to A dot B cross C, which is also equal to B dot C cross A, which is also equal to C dot A cross B. So always make sure that this A to B to C to A. This cycle should be maintained. That's the wrong way of writing. So we have A to B to C and then C to A. The cyclic way of writing should be always present. So ABC, BCA, CAB, right? ABC, BCA, CAB. That cyclic order should be maintained, because if not, the value differs and then the answer goes wrong. Another property that we need to understand is, which I would say should be understood with much careful attention. So we have A dot B cross C is equal to minus A dot C cross B. Why? The logic should be very clear to you now, right? So B dot C cross A should be equal to minus B A cross C. C dot A cross B will be equal to minus C dot minus B dot B cross B cross A. Now why is this minus coming up? Right, so I hope you have the point here, right? So just an extension of what we discussed in vector product. Okay, right, so that's it. So we discussed what scalar product is, we discussed the properties, we defined them. Okay, now let us see how did we come to this determinant. So vector A dot B cross C is defined as the determinant of what? Determinant of A1, A2, A3, B1, B2, B3, and C1, C2, C3, where what is vector A? Where vector A is represented as A1 I cap plus A2 J cap plus A3 K cap, and vector B is represented as B1 I cap plus B2 J cap plus B3 K cap. Okay. So while discussing about the proof of this, that wouldn't make sense here. Now let us see the practical application of this. What does this mean in a three-dimensional axis? Okay. Before we go to the application, we can also write down another property, which is A dot B cross C is equal to B cross C dot A. Very basic, I know that. The commutative property of scalar product is something which is very clear to you, but I was just no thought of adding this point also. So B dot C cross A would be equal to C cross A dot B. C cross A dot B. Right, so that's also one more thing which I want to add it. So we discussed about we saw the determinant, we wrote the scalar triple product, the definition, the basic identities, how to find them using determinants, and moving on to the geometrical interpretation, which is the physical application. So, which is something we should be definitely discussing. So, say I have three vectors here. Okay, the three vectors here. Like this. So I got vector A, which is vector 1, another vector B, okay, and one more vector C. So, okay, now this diagram is always pretty confusing. If I complete a three-dimensional figure here, complete a three-dimensional figure like this, inclined like this, like this, right. So we got three vectors, vector A, B, and C. Okay. So we know from the very definition of cross product that if theta is the angle between A and B, then this vector over here, what does it represent? Right, it represents the cross product vector A cross vector B, right? Now in this case, it is this figure what we call as a parallelepiped. What is a parallelepiped? It is nothing but a three-dimensional parallelogram. So parallelogram in 3D is what we call as a parallelepiped. Now, why is scalar triple product applicable here? Because it is this triple product, the scalar triple product of these vectors, right? The scalar triple product of vectors A, B, and C actually give us the what? Give us the volume of the parallelepiped, right? Another thing that we if a question is asked, what is the geometrical interpretation of triple product? What is the geometrical interpretation of triple product? It simply means that the triple product represents the volume of the parallelepiped, which is formed by the three vectors A, B, and C, making it the adjacent coterminous sites. Now that is really important. Adjacent coterminous vectors. So only if these three vectors, vector A, vector B, and vector C, are coterminous, then the parallelogram in 3D, the volume of that parallelepiped will be represented by the scalar triple product A dot B dot C. Okay, now one more thing that I wanted you to understand, which is of significance since the question is based on that, is that scalar triple product can be used to check coplanarity of vectors. Check coplanarity of vectors. What do we mean by that? What we mean is, if the scalar triple product ABC is equal to 0, then it means that vector A, comma vector B, and vector C are coplanar vectors. So what does this mean? Okay, if we need to understand the coplanarity vectors, we need a diagram again. So before drawing the diagram, let us see, if triple product ABC is equal to 0, it means that vector A dot, right? Vector A dot, vector B cross C is equal to 0. Let us divide this in two parts. We have a dot product and we have got a cross product. What is the cross product? The cross product is vector B cross vector C. And what is the dot product? It is vector A dot vector B cross C. Okay. So what is given to us is that this value is 0, because it is given that triple product ABC equal to 0. So if triple product ABC equal to 0, it means that A dot B cross C equal to 0. Now what is the meaning of saying vector, if A and B will be confusing again. What is the meaning of saying vector X dot Y is equal to 0? If X dot Y is equal to 0, it means that X is perpendicular to Y, right? X is perpendicular to Y. Why? Because X dot Y is xy cos theta, and cos theta is cos 90. Cos 90 is 0, so we get xy into 0, which is equal to 0, right? So if dot A dot B cross C is equal to 0, what should it imply? Right, it should imply that A, vector A is perpendicular to B cross C. How? Let us understand that too. So say we got a plane here. Okay, we got a plane here, and there are two vectors. Which are the vectors? Say this is one vector, vector B. Okay, and we have got another vector, vector C. Now by the definition of vector product, we know that the cross product, which is actually B cross C, is nothing but a third vector. I repeat, vector B cross C is nothing but a third vector. So let us say vector D. vector D, which is perpendicular to both vector B as well as vector C, right? So this is the definition of cross product, which means this vector D represents vector B cross C. So although B and C are on this plane, whereas B cross C, it is not on this plane. It is in fact perpendicular to this plane, which is represented by vector D here. Now, instead of writing B cross C, what can I choose? I can choose the letter T. So I'll write here vector A dot D is equal to 0. And if vector A dot D is equal to 0, what does it mean? It means that AD cos theta is equal to 0, which means either A is equal to 0, which is not the case, or D is equal to 0, which is not the case, which means the only possible scenario is that cos theta is equal to 0, and therefore theta is equal to pi by 2. What does it mean? It means that the angle between D and A is pi by 2. And if this vector D is perpendicular to this plane, any other vector which is perpendicular to it, where will it lie? It will lie definitely in this plane, because only then another 90 degree, another perpendicular vector will be formed, and therefore vector A is basically lying here. So from the figure, what you understand? From the figure, what you understand is vector A, vector B, and vector C are coplanar vectors, which is basically what's been asked in the question. And therefore the det of these vectors should be equal to 0, right? There's another property which may be useful, which I think is even applicable in this question. Yeah, it is applicable in this question. I'll explain that point also. So see, coplanarity can be found in a different way as well. So coplanarity can be checked if vector C can be expressed as L into, which is a scalar, into vector A plus M into vector B. So if this condition is also satisfied, where L and M are scalars, if this condition also is satisfied, we can say that determinant ABC is equal to 0. So that's all with scalar triple product, and question number 17 for you. Let's move on to the next question.